everybody, this is Aurora with Supercharged Science, and we are going stargazing tonight. Can you tell? We are going to have some fun tonight. So my name is Aurora, and we are going to be starting our science series in astronomy. Now, I know people are just going to be jumping on for the next couple of minutes, so I wanted to start a little bit early tonight. So I'm going to introduce myself. If you can hear me and see me, give me a thumbs up so I know the microphone is working. Let me know that you can see and everything's going great. My name is Aurora with Supercharged Science, and we're going to be stargazing very soon. I'm here a few minutes early so you can give me feedback on the microphone, tell me how it's going, how's everything sounding, give me a thumbs up like I can hear you great. Tell me if I'm too loud. We've been having some microphone issues, so we have like microphone number 15 we're trying right now. But I am so excited. We are going to be doing some real stargazing tonight. It looks like I'm in a telescope store, doesn't it? This is only about a third of my telescopes, but these are the ones that were small enough so it would fit in the camera. And so I'm going to be introducing them to you. We're also going to be talking about how to read one of these confusing things, these star maps, as well as the larger one that I have a link to in the description as well. So you can check that out. We are going to have a total blast. So if you've got kids at home and kids, you are ready to learn some real astronomy from a real astronomer, then this is the perfect place for you. So go ahead and let's get started. Oh, those of you who are just joining us, my name is Aurora with Supercharged Science. I'm going to put a link here to, of course I didn't type it in beforehand. There we go. So if after we're done today, go to the link I just put in the comment section so you can download your free astronomy lesson packet I put together for you. Inside that packet, there's a, do you guys like to play Monopoly? I actually created Spaceopoly, and I gave it to you completely, free of charge. You just, you go to that link and you can download that stuff. There's a Black Hole Explorer game, which was developed by NASA scientists. That's on there as well. If you're interested in buying a telescope, my guidelines for how to do that as well are on that link. So you can go to superchargedscience.com/astronomy. Now, I know with Facebook Live, people like jump on and off all the time. We'll just give people like another minute and a half, and then we'll actually start. So if you want to shout out, give me a, tell me your name and what city or state you're from in the comment section, and I can say hello to you. This is a real live class, and I'm super excited. And we're going to look at the stars. I'm going to show you some things on my desktop. I'm going to show you what's up in the sky tonight, and also how you can customize that for where you live, because depending on where you are on the planet, you're going to see different stuff, but I'm just going to show you how to run through it just as an example. I'm going to show you how to read some star charts, and that way you'll be off and running. All you got to do when we're done with class is go outside and look up. Now, if the weather is really bad, don't worry about it. You don't have to go out there tonight, but you'll know once the clouds clear and the storm passes, you'll be good to go. The skies do change from night to night, but they don't change that fast. So we usually think of the skies as having 4 major seasons, the spring, summer, fall, winter. And so right now we're late winter, early spring. And so that's the part of the sky actually the least number of people know, because usually stargazing events tend to get canceled because of weather, winter storms, spring showers, that kind of thing. So this is an area where a lot of people are just not quite comfortable yet. So anyway, we're going to be doing this tonight. Oh, hi Hunter from Australia, welcome. We also have Teresa, who has triplets from Minnesota, 9-year-old astronomers. Welcome, welcome everyone. If you want a quick little shout out, just write me your name and where you're from, and I can say hello, a personal hello to you. Have you guys enjoyed the lessons so far this week? Hasn't that been fun? We've been doing rocketry and catapults. We did holograms and taught you all about lasers. So you could do laser light shows in the bathroom. We actually have a lot of really cool projects lined up for this coming week. We're going to be doing a lot of astronomy and showing you how you can take physics and chemistry and apply it to a field, a scientific field. So we're going to be doing physics, chemistry, but we're going to apply it through the lens, pun intended, of astronomy. And so you will be able to do a lot of really cool stuff. We're going to talk about black holes and planets and stars and atmospheres and you name it, it's going to be in there. So let's see, we have 2 learners from Japan. Well, good morning, Lisa. Hello. And then we have Joaquin and Zelda from California. Welcome. We have Thomas from Maryland and Lonnie and Aiden from Utah. Hello, welcome. All right, we're going to go ahead and get started. Give me just a second. I'm going to fix something here. Hang on just a minute. How is the microphone? Everybody good with that? Microphones are good? Okay. All right, everyone. Hello and welcome. My name's Aurora with Supercharged Science, and we are going to be doing stargazing. Doesn't it sound cool? I mean, look at all the telescopes and binoculars I've got around. So I'm going to take you on a personal tour through the night sky. So by the end of tonight, you will be able to make sense of one of these confusing star maps. Don't worry if you haven't printed yours out. I'm just going to take it from the top. I'm also going to teach you how to read an almanac, as well as we're going to talk about binoculars and telescopes and how to tell which ones are really good choices, especially for kids to have. And so if you like this and you want more, I put together a set of astronomy lessons that you can download. It's a packet. You can actually access it online. It's www.superchargedscience.com/astronomy. You just put your email in there, and then I send it right to you. And so that will be yours for free as a follow-up from tonight's stargazing. Okay, so you go outside and you look up, and what? You see stars, right? Instant success for the hobby. The trouble is, it looks usually like this, and people have absolutely no idea what they're looking at, right? And so how do you do that? Like, how do you know what's what? You know, I've got a couple of little big star names in here, but how do you tell what's what in the night sky? Okay, so that's what we're going to take from the top. Now, even if you've never done any stargazing before, if you don't even know where Orion is, no problem. We're going to take it from the top. Okay, so one of the things I want to start off with is one of these things. Usually people will print these out or they'll give them as presents to kids. And then the kids are like, oh, this is so cool. How do I use it? So really quick, the way you normally use these, if you look on your copy, actually I think I have a copy here so I can show you on my desktop. Well, it doesn't matter. You can imagine. This says east, west, north, south. Okay, so you'll see little words written, and what you're supposed to do is you're supposed to put it over your head in that orientation. So if I'm facing north, the north part of this, so it would go like this, would be over my head, and the idea is what I'm looking at above my head should match when I take the paper away. Now, today we have apps on our phone, and so Sky Safari is a great one. There's a lot of them out there that will help you, so you can actually put your phone up and it'll show you what you should be seeing. They're a lot easier than using this. The trouble is you don't get a good view of what it is because usually they're so zoomed in. It can be difficult to figure out, like, well, wait, what else is out there? So there's pluses and minuses to both. Being able to use both of them is really ideal. So instead of spending a lot of time with a paper copy, so now you know how this works, right? It goes over your head. And so if I've got, like a constellation over here I want to look at, it's more to the west, I'm going to look west, and I'm going to try to figure it out. The other problem is this is flat, right? And you've got this huge dome over your head. So the paper ones are great for kind of looking at what's up in the sky, sort of. But it doesn't give you a real sense of the distances between the different objects that we're going to be looking at tonight. So instead, what I thought I would introduce to you is something that not a lot of people use, which is too bad. Well, not for long, right? It's one of these. It's called the Sky Gazer's Almanac, and Sky and Telescope publishes this every year. I can't show you 2020 because we're not the publisher, so I can't share that with you. You have to go buy it for $5 from their website. But so we're going to go through the 2019 version. Same thing. And so I'm going to walk you step by step how to read this. It'll take about 5-8 minutes, and then I'm going to show you how to find stuff in the night sky by using the software that's on my desktop. So it'll be like a planetarium star show just on your computer screen. So if you have anybody that you know that loves astronomy that should be with us right now, make sure you invite them because we're just about to get started. So if you got your popcorn out, that's great. Something else you're going to want is a pencil and a piece of paper. So anytime I'm talking and I say, oh, you've got to check out M42 and Orion's Belt, super easy. You can see it with a naked eye. If you're in dark skies, you're going to be writing M42. So you don't have to remember all this. This video will be archived by Facebook Live. It does it automatically, so you can always find all of our Facebook Lives in the video library on our Facebook page. Okay, you guys ready? Looks like most people have jumped on. This is fantastic. All right, let's get going. So how do you read this thing? Now, one of the first things I want you to notice before we zoom in on it is, do you notice how it's fat and then skinny and then fat? There's like a squeeze in the middle. That's because time goes this way across it. So this is sunset and midnight and sunrise. And so in the wintertime in the northern hemisphere, we're going to have a lot longer evenings. And then around here in June, the evenings are going to be much shorter. So that's why it kind of looks like that. And then down here in December, the nights are much longer. And so that's kind of why it looks like that. Now also, do you see this blue haze around here and around here? That's because as soon as the sun goes down, it just doesn't suddenly go from light to dark, right? It's a gradual progression of twilight. And so it will show you the 3 different stages of twilight in there in that fuzzy, hazy section. Okay, so let me show you my copy. If you don't have a copy of this, don't worry. It's in the description. You can download it later. Let me show you my copy. I'm going to zoom in and be able to point to things, and then you guys can shout back the answers as I'm asking you. You ready? So just pretend I can hear you right now, like we're totally talking, like we're having a conversation about astronomy, and let's get going. If you are ready, say, oh yeah. Okay, so let me pull this up. So here's the almanac that I was just showing you, and I have a nice big version of it here. Oh, actually, this is 2020. Okay, so this is for tonight, actually. Okay, so here we go. So I can't give you a link to it, but apparently I can show it to you. Okay, so I actually keep this thing by the back door because so when we head in and out of the door, especially at night, we can quickly just look and we can look across and see what's up in the sky tonight. All right, so how do we do this? All right, so notice that the time starts 5 p.m. here. Can you see that? Can you see my cursor over here? About 5 p.m. and it progresses all the way across here till 7 a.m. Okay, and these are the dates. We got January, February, March, all the way down to December. And notice we got a 5 and a 12 and a 19 and 26. Okay, so what do you do if you want, you know, like January 6th? Like, where is it? See, each one of these dots here, that is actually a day. So each dot represents a day as we go vertically up and down, right? So we got 5, and then we got 6, 7, 8, 9, 10, 11, and then 12 makes this point right here. And I need a different pointer other than this. Okay, I will see if I can change my pointer. Nope, I've got a hand, and that's it. Let me see. We want, not that one. Select tool. No, okay. All right, well, I'll figure that out later. Okay, now one of the things I want you to notice is that as we go across here, so up and down, each dot is a day, and as we go across, do you notice how the time is progressing till we get to midnight, and then we've got this this meridian here, and then we got 1, 2, 3, 4, 5, 6, 7 a.m. So each one of the dots going vertically is 5 minutes. So we have 10 in here and 11 over here, right? So halfway between 10 and 11 is 10:30. And so each dot is going to be 5 minutes. So 10:05, 10:10, 10:15, 10:20, 10:25, 10:30. Does that make sense? Awesome. Okay. So let's take a look. So let's find our day today. So where are we? So this is a great time to grab a ruler, or you can even put, especially if you don't have a touch screen, you can put a sheet of paper up to this because there's a lot of information on here. You're noticing these big, different multicolor lines. So each line is a different planet, and we're going to find when Venus is setting tonight. Now, what is today? March 21st, right? So we have March. Now we have the 22. Okay, well, that's close, right? March 22 is pretty close to 21. Today's the 21st. So let's just use 21, and then when we hit the line, we'll go up one. So we're going to go March 22, and so we're going to go all the way over, and then we go up one, and it looks about here. Yeah, but what time is that? Yeah, we lost our top, didn't we? Okay, so look here. So we have 10 o'clock is here. I'm going to leave my cursor on 10 o'clock. And March 22 is here. So it looks like it's not quite 10:30. So this line intersects March 21st, right about here. So you can say that Venus sets between 10 and 10:30. So about 10:15, Venus is going to be setting. Isn't that cool? And you can kind of see what Venus is doing over the course of several months. This is how this is much better than one of those sky charts that I was just showing you initially. Isn't that cool? Okay, so when is Saturn up this year? Okay, Saturn. Now we got to find which line Saturn is. Okay, here we go. Saturn. Saturn is yellow, nice and bright. Saturn rises. Here we go. So when is it up? It's a yellow line. And do you notice that over in March, you see it over here? Saturn is up, it's this yellow line, but it's not up until what time of day? Late at night or early in the morning? Yeah, early in the morning, right? So if you want to see Saturn tonight, you're going to have to go March 22nd. Here, we're going to follow this all the way over. And then notice how March 22nd, this line, if you follow it over, it turns into March 23rd. And you're like, wait, what do you mean? We started on the 22nd. That's because March changes, the date changes at midnight. So March 22nd, and we hit midnight, and then it's going to turn into March 23rd. Make sense? So we're going to be one dot up, okay, so about here, and Saturn is going to rise at right about there. So what time is that? It's after what time? It's after about 3 o'clock. So about 3 o'clock in the morning, probably closer to 4. If you go outside and look up, Saturn will be rising in the east. Isn't that cool? Okay, so now where do we have a lot of planets all lined up at the same time? Yeah, there's a lot of planets here. Let's see. What if we scroll further down? Whoa, look at all these planets. All these lines are planets. Yeah, okay, let's pick one. Say like August 30th. You see that? So if you go outside on August 30th and you take a peek at this chart before you head out, you're going to notice, you're going to be like, okay, I'm going out, and then I hit a green line. Before it even gets dark, what is that? That's Neptune is going to rise. Okay, so you look east, Neptune rises, but usually you need a telescope for that, so let's keep going. Okay, and now we have Mercury is setting. So you'll look and you'll see a star low object set in the west. So you'll look and you'll see an object really low, and then it'll set. And so that's how you'll tell, oh, you know what, that was Mercury. And then if you just keep looking up, and as the night goes on, we'll get this pink line. Now this pink line is Jupiter transiting right there. Transiting, what does that mean? That means that Jupiter is directly overhead. Okay, so there are 3 different lines that can be on here. So the planet could be rising, it could be transiting, or it could be setting. Make sense? So it kind of gives you an idea of where to look. So if Jupiter is transiting at about, let's see what time it is that. Jupiter, here, we'll go down. Jupiter is transiting right around 8 o'clock. Okay, right around there. Okay, and then as we move over, we have Mars is the red line. So we're going to see Mars is rising. Okay, so here we go. Okay, so we have Jupiter, we have Mars, and then we have this green line. So we'll look over here. Uranus is rising. Let's keep it closer to astronomy than anatomy. Uranus, say it after me. Uranus, very good. Okay, so we have Uranus is here. And we have Saturn is transiting. What does that mean? Where's Saturn going to be? Is it going to be the east or the west? Yeah, neither, right? It's going to be overhead. Good. So just by going out on August 30th, you can see all these planets doing stuff. Isn't that cool? Now tell me, is Venus in here anywhere? Where do we have to go to see Venus? How late do you have to stay up? Yeah, you got to go all the way over here, right? We're going to pass midnight, and then we'll come over here, and Venus, it's going to be like 2 or 3 in the morning, right? That you're going to see Venus. And then we have it goes into August 31st. So isn't that cool? Do you kind of see how this works? And just with one glance, you'll be able to tell like, oh, this planet and this planet. And parents, are you seeing an application for math in here anywhere? I sure hope so. Okay, so you get kind of a feel for how this works. I want to point out a couple of other things that I want you to take a look at, because after you get the hang of planets, you start to see other things on this chart that you didn't notice before. Check this out. So you see the moons all over the place? Okay, so this tells you where the full moon is when it's a great big moon. And, you know, of course, you've got the different quarter moons and then the different phases of the moons all throughout here. So you tell me, when is there a full moon in August? You tell me, when is there a full moon in August? Do you want me to zoom in on it? Here, let me zoom in a little bit. Sorry, hang on just a second. Zoom in. Didn't mean to zoom in quite that much. Okay. All right, where is the full moon in August? Is there 1 or 2? Yep, there's 2, isn't there? Yep, it's right over here. Notice it's not really on the center line, so you can say, oh, you know what, there's going to be this is the moment it becomes a full moon for us. So it's going to be August 3rd and whatever time this is. If we go up there, we can find the time index. Okay, and then there's another one. Isn't that cool? And so at these dates, this one here, this is a new moon, and these are the phases. Isn't that cool? Okay, so let's go over here. Now imagine you are a fan of meteor showers. Which marks on here, let me zoom in a little bit. Which marks do you think are meteor showers? Yeah, the big splats. Now, meteor showers will usually last a couple of days, but these are when the peak is going to be at. And so if you really, really want the best chance of seeing the most meteorites, then you want to go here, but really it's anywhere in these couple of days. So this one, the Delta Aquariids, are going to be right around what day? Yep, July 27, 28, 29, right in there. Okay, and is it early in the day, or early in the night, or is it early in the morning? Yeah, it's after midnight, right? So here's the median. So it's going to be early in the morning. So you're going to have to really talk your parents into staying up super early, or getting up super early, right, to go see those. You got to make sure when you're looking at meteor showers that this mark isn't next to one of these marks, because if the full moon's out, how many meteorites are you going to see, or meteors are you going to see? Yeah, not very many. So, for example, the ones that are in December are really well placed because they are right around an early phase of the moon, which is super cool. Okay, great. So how are we doing so far? Oh, by the way, in case you've just jumped on and joined us, my name is Aurora with Supercharged Science. We are getting ready to stargaze. We are learning how to read different maps and charts. If you have questions throughout the entire class, just write it in, or if I ask a question and you want to shout it back at me, you can totally just talk to me. And you can also type it in the comments box. So if you have a question, feel free to type it in anytime. And for those of you who just joined us and missed the announcement, I put together an astronomy packet. You can get it at superchargedscience.com/astronomy. So www.superchargedscience.com/astronomy. You can download that packet when we're done. Okay, so there's a couple other things I want to show you. So let me do that here. Let me zoom out. Now, eventually, you're going to look at this thing long enough and you're going to go, whoa, Aurora, what is this? Sun slow. Like, how is the sun slow? And actually, if you keep going further down, it'll say, you guessed it, sun fast. Okay, so what's going on here? Okay, so this line, and if we zoom out, you can see it a little better. Do you notice how it kind of wiggles back and forth? It kind of weaves back and forth. It's a really faint line. Weaves back and forth along the meridian here. Okay, so what's going on with this? Well, this is called the equation of time, and it's kind of complicated to explain. But imagine the vertical line that goes up and down here is noon, not midnight. And then maybe this will make more sense. And the second one, the line that weaves back and forth, that's actually when the sun crosses the meridian. So, for example, on February 23rd, here, look. So we'll look at when the sun is slow. Okay, do you notice how it's on this side? Okay, so this means that the sun is directly overhead, crossing the highest point of the sky, but it doesn't do it at noon. It does it at 12, let me see, 5, 10, almost 15, so maybe 12, 14. So that's what we mean by the sun being slow. The sun should have been at its highest point of the sky at noon, but it wasn't. It reached its peak at 12:14. So this small variation is due to the fact that the Earth's axis is tilted and some complicated mathematics that way. But what I want you to notice is that it never gets that far. So it's either usually slow within 15 minutes, plus or minus 15 minutes of the sun reaching its highest point in the sky. So that's what that's about. Okay, so I have a question for you. Did you notice on this chart that a lot of the colored lines, Neptune, Uranus, Jupiter, Saturn, the lines are straight. When we get to Mercury and Venus, they're curved. Now, what are your ideas there? Why do you think that is? What are your ideas? Tell me out loud. I'll give you about 10, 15 seconds. Ready? Go ahead and go. Why are those curved? Give me your best guess. What do you think? Any ideas? Why would they be curved? Okay, it's because those are interior planets, meaning that when we look at them, they never get very far from the sun because they're closer in towards the sun than we are. And the ones that are further out have a much longer orbit. So we're going to be seeing less of them. So their orbits are much longer, so they appear to be a straighter line. In fact, if you look at this, Mars, which is pretty close to us, well, close, relatively close, is a curved line. It's like a curved line trying to be straight. So you can kind of see that effect happening there. Okay, there's one more thing I want to point out because usually somebody will ask, and it's right here, look at this. What do you think this mark is? Let me see here. Come on. For some reason, it is not zooming in for me anymore. What's going on? Okay. Oh, there it goes. Okay. So what are these little marks? Do you see them here? They look like a little circle with an ear on them. You see that? Okay, so what do you think they are? What's your best guess? Any ideas? Take a look. Where do they appear? They appear when the planet lines cross. So what do you think that means? So astronomers get really excited when they look up in the sky and 2 or more objects are all in the same spot. In fact, they have a special word for it when 3 of them are in a line, a rough line. They call it a syzygy. Talk about a great word for Scrabble. So anytime you have a couple of objects, like at least 2 objects together, that's going to be called a conjunction. And so you can look up in the sky, you can see like the moon and Jupiter, or you can look and see Saturn and Jupiter, which is the really big one this year, and it's happening around Christmas time. So people are really excited. You're going to be able to see Saturn and Jupiter close, so close together that when you look at it through a telescope, they'll be in the same eyepiece, which like never happens. So people are really excited about conjunctions. Okay, so how does that feel? Does that kind of give you, even if you didn't follow everything, do you kind of get the feeling of how you could learn how to use something like this? Kids, do you think you could figure out what's up in the night sky tonight? Absolutely. So let's take a look. I'm going to show you what the northern hemisphere, about 40 degrees latitude, is going to look like. You can adjust this for your own latitude. If you're in Australia, you can totally adjust this. This program is called Stellarium. It's free. Here, I should probably type it in the comments. It's a free program. Don't get it now, just get it later, that you can download and put on your computer. You put in your own home address, your zip code, and it knows exactly where you are, and it adjusts the stars for what you'll be seeing tonight. Okay, so if you and I were together and we were going to go outside and stargaze, this is what we would see. So let me teach you how to stargaze the easy way. Ready? Here we go. So we're going to close our star chart there. Okay, so we are looking here. And do you see how there's these little markers down here? That one says S for south, southwest, and west, okay? Now you'll notice there are these little stars here, right? These little points of light, okay? But how do you know what they are, right? How do you know? Okay, so there's an easy way to do this. Let me grab my notes here. Here we go, okay. Oh, actually, let me pause just for a minute and make sure, before we dive in here, make sure there aren't any questions that are coming in. Microphones are good. Excellent. Okay. Let's see if we had any questions come in. Not really. Okay. Okay, great. Let's keep going then. Okay. So the first thing I want you to do is let's take a look and see if we can find Venus. Now, where would Venus be? Okay, so when we look in the night sky, if you're in the northern hemisphere and you're facing south, there is going to be, here, let me show you my face. There's going to be this arc that you can watch throughout the day when the sun makes its travel across the sky, as well as the moon, and the planets follow that same line. It's called the ecliptic. And so if you look on that line, it's the same line that the path that the sun traced out over the course of the day. If you look on that approximate line in the evening and you try to find stars that don't twinkle, most likely those are going to be planets. And an easy way to find out if they're really a planet or not is with a pair of binoculars. Now, I'm going to say make sure you never look at the sun through anything with lenses, because your eyes will be toast and you will get permanent blindness. So this is at night. You can use your pair of binoculars, look up, and if through your binoculars they're definitely not twinkling, chances are it's going to be a planet. Now, what's really cool is if you went at a time where you could see Jupiter and Saturn, actually you can see Jupiter, but it's like 3 o'clock in the morning this morning, and you look through binoculars, you will actually see 4 moons of Jupiter. So you'll see Jupiter, and you'll see a bright dot, and you'll see 2 dots on one side and 2 dots on the other, or sometimes it's like 1 and 3. And, excuse me, but they'll all be in a straight line. Those are Jupiter and its moons. And you can see that with a regular pair of binoculars. How cool is that? So how do you do that? How do you know which ones are out there? Okay, so during the day when you look up and you kind of notice kind of where the sun is, you kind of make a note, or if you have the moon as well, that'll kind of mark it out for you. And then you just go back out at night, you kind of look in that same area. And if you see a star that's been there, but it's kind of changing faster than any of the other ones, or again, if it's not twinkling, chances are that's going to be a planet. So look over here, and if you take a look, we have something over here that isn't normally there. Now, Sirius is the brightest star is one of the brightest stars in the entire night sky year round. So anything bigger and brighter than Sirius, chances are it's going to be Venus. Now, Venus is going to set tonight. Remember, it was like 10:15, 10:30, something like that. So this one here, if we click on it, we can actually see, oh, whoops, is that the moon? Hang on, sorry. Let me get oriented. Okay. So chances are it's going to be Venus. So the moon is on an ecliptic as well. So let's see, where's Venus? Let me get oriented on our planet here, on our star. Here we go. Okay. So we have the moon that's going to be setting later tonight. So is there any constellations that you notice here? If I take the star names away, this is what you're really going to see, right? Is there any star formations that you notice? Any at all? I'll give you a hint. What if I do this? Do you notice any of them now? You recognize any of them now? What do you think? How about this guy here with his belt and his shield and his sword? Starts with an O, sounds like Orion. So this is going to be Orion. Now I'm going to take these labels off and you tell me if you can see it again. Can you see him? Okay. With your binoculars tonight, you can find Orion. You're going to look for the 3 belt stars, and then you can drop down here and look at the 3 stars in his sword, and that middle star is a place where baby stars are being born. So let me show you. I'll put the labels back on just because you're getting new to this. Okay, so we're going to zoom in right there. Okay, and we're going to come take a look. Now this is a Hubble image. This is not what you're going to see through your binoculars, but this is a Hubble image of what is happening here. There's a nebula, big gas cloud, and the trapezium, which is a 4 stars, if you can see it, in there that are brand new. And they're so overexposed you can't actually see them because they're just blurred in here. But this is a place where there are tiny little stars. Okay, so you kind of see where that is. So here are his belt stars, and you go down, and you will see, if you look through binoculars and you look down here, you will see a fuzzy patch. It will not look like a star. It'll look like a green fuzzy patch. Isn't that cool? Okay, so let's try to point out some of the brightest stars. You got it? Okay, so for example, we have Orion. We have Orion here. Here, let me turn off the constellations. Okay, so we have Orion here. We have his belt. Okay, and we have a foot. Now, Orion has a dog. Sirius is the brightest thing you're going to see most nights. So if you go outside and you see a lot of pollution, a lot of light pollution, you will be able to see Sirius. And this is the dog star. This is the eye of the dog. Here, we'll connect them again. Okay, you kind of see it. It's right around his chest. Sometimes people think of it as the eye of the dog. Okay, so this is the dog star, and this is Sirius. And this is actually a double star. If you were to zoom into Sirius and look at it with a big telescope, you would actually see, let's see if it actually will show us a double star. Yep, you can see actually this is a double star, a binary that you can see in a telescope. Now, do you notice how this is drifting slowly? That's because that's what's going to happen when you're looking through a telescope, something that's mounted to the ground. You're going to see the stars slowly move through your eyepiece. Now, we can stop that because we want to be able to look at stuff, okay? But that drift is what's happening because the Earth is rotating, right? In the night sky, everything's moving, okay? Okay, cool. So now I know with the stars and zooming around, if you get a little dizzy, all you have to do is close your eyes just for a minute and that dizziness will pass. Just like if you're in a real planetarium and you get disoriented because the stars are moving in a strange way. Okay, so if you're wondering like, okay, so Orion's here and we have a dog here. You know, how does that look like a dog anyway, right? How does that look like a dog? If you're looking at it, here, let me take that off. It doesn't really look like a dog. Well, it's because people back then had really good imaginations, right? This is what they saw when they looked in the night sky, right? So we have the dog, And then we have Orion, and then we have Taurus the Bull. Now notice Taurus has a red eye here. Let's check that out. So when you have Orion, you got the dog star. And then if you go the other way, so tonight it'll be closer to the moon. If you go the other way, you're going to see like this triangle. You see that? That's the red eye. That's Aldebaran. So it's the red star in Taurus the Bull. Okay. Now, what are some other really bright stars? Does anyone have the astrological sign Gemini? Okay, do you see Gemini anywhere up here? What if I help you out? You see them? Gemini is right up here. See the twins? Okay, so they're two parallel lines and their heads are really bright. So let me turn it off so you can see it again. Okay, do you see them now? You see the twins? You see how there's the pattern? So the way you do this is you find bright stars and then you start to get to know the patterns, because the patterns don't change throughout your lifetime. Or typically they don't change throughout your lifetime. Okay, I know weird stuff is happening with Betelgeuse right now in Orion, but we're not going to talk about that just yet. So we have Orion, we have his belt star, we have Sirius the dog star, we have the red eye of Taurus the bull, and then straight overhead tonight, so when you go in the northern hemisphere, you folks can go out and take a look, and you will see the Castor and Pollux. And Castor is actually the, here, let me put the star names up, is actually the smaller one, and it's a double star. And you can see that Pollux will be the brighter one, but Castor is actually two stars stacked on top of each other. And I don't think this program's going to show me that. But if you look at it through a telescope, oh, maybe you can see it a little bit. It'll actually have, there it is. It'll actually be two stars, a big star and a tiny star. Okay. All right. You guys ready to take a look at some other really cool things? How are we doing so far? You guys liking this? Tell me in the comments how you're doing, so I know, because it's a little one way right now, so I know how you're doing and how things are going. If there's a certain constellation you'd like to see, let me know. Okay, so let's take a look here. So how do you find more stuff? Okay, so how do we find really, really cool stuff? Okay, so M40, okay, so we talked about, here we go. Oh, I should probably explain about the Messier catalog. Okay, so really quick. So if I say M41, M42, we're going to look at both of those. M44, I'm going to show you that one too, the beehive cluster. That M stands for this guy named Messier, so Charles Messier. So he was excited because he wanted to be known to the world as the guy who discovered all the comets. Well, the problem is every time he looked in the telescope, other things got in his way. Planetary nebula, double star clusters, open clusters, galaxies, and he got really annoyed and irritated. So he finally went, fine, I'm going to make a catalog of all the things not to look at. And he made this catalog, which is the Messier catalog, which is over 100 objects. And so M is for his last name. So we have M41, M42, M102, M101, M52, M1. I'm going to show you M1 in a minute. That's the Crab Nebula. It's a pulsar. And so he got really annoyed. Nobody remembers any of the comet work he did. What do we know him for? For his list of all the terrible things to look at, or the things not to look at. So it's kind of funny, but anyway, so be careful what you record, because you might get known for that. Okay, so here we go. So we are going to take a look at M42. I'm going to show you where that is, and then we're going to take a look at M41. All right. So where are we? Oh, we're in Capella. Okay, so let me see. Oh, and let me show you, if you are planning to use this program, you just you hit this little magnifying glass with a star, and you just type M42, enter, and shoom, there you are. And it tells you all the data about it, but we can get rid of that. Okay, so where are we? Where is M42? Where is it? Do you recognize this guy yet? I hope so. That's Orion. That's right. This is the one I told you to look at where baby stars are. Yep, right in there. Excellent. So that's M42. There's a ton of stuff in Orion that you can look at. Here, we'll start to put some, whoops, here we don't need all the labels on. There's a ton of stuff in Orion that you can look at. And let's take off the atmosphere. Okay, and so this is what it's going to look like on a super clear night. Do you see how many stars there are? You see how it's really easy to get confused? So it's important, people that would navigate by the stars, they would have certain patterns that they recognized, like Sirius and Rigel and Betelgeuse. They wouldn't count on the moon. They would know the phase it was in, but that wasn't something they would use to help them navigate by the stars. Okay? So, alrighty, now we are on our way to, oh, I want to show you another open cluster. Okay, so if we look here, this is an open cluster. There's another one here, the Heidi's is here, and then this one is gorgeous, and your parents probably already know what it is. And if I show you the picture, parents, can you tell me what this is? Here, don't worry about the star names. In fact, let me get rid of them. Okay. Have you seen this cluster before? It's called the Seven Sisters. Pleiades? Okay, so you'll be able to see this. It will fill the entire field of view with your binoculars. So how you find it, it's going to look like a little starball patch in the night sky. So let me show you what it's going to look like. So we'll be out there, you and I, and you're going to see Orion. It's going to look like that. You're going to remember Orion. We'll look over here, and you'll say, oh, yeah, look at that V. Look at that triangle, Aurora. That's red on one side. Oh, yeah, that's the eye of the bull, Aurora. And then you're going to hop over. See how far you went to get from Orion to the triangle? Yep. Then you're going to hop over here and say, oh, you know what, Aurora, this is the Pleiades. You should check this out, M45. And that's right there. Okay? So those are three objects that are really cool to see that are all really close to each other, and they're all open clusters. This is part of another open cluster, but it's so big, it's hard. You can't get it in one field of view. This one you can, which is really cool. And this one is so compact that the whole thing fits in there. It's pretty small. Okay, so Canis Major is the dog, which is here. If we turn on the lights, you can see Canis Major is Sirius, the dog that we talked about. Canis Minor is actually riding on top of a unicorn. Let me show you. Okay, there, do you see him? Canis Minor. He's like, nobody ever pays attention to him because it's two stars connected by a line. So you've got Monoceros here, which is the unicorn, and if we take off the pictures, you can see Canis Minor is just two stars, so we don't really pay much attention to him. Okay. Now, M41, if I told you to go find M41, you had no idea. You would just type M41 in here, and let's go find him. You would find it, use a star chart, and you'd say, hey, wait a minute, it's in Canis Major. Okay, I know Canis Major is the dog constellation. What is M41? Let's take a closer peek. In a telescope, it would look like this. Isn't that cool? So this, what you see on the screen, is what it would look like with an 8-inch telescope. With binoculars, it's going to look a little more like that, and you'll see a fuzzy patch with some bright little pinpoints of light, just like this. All right, and so if you want more information about this type of thing, you can totally, you can look that up when you click on things like that. Okay, so let's see. So, oh, for those of you who are just joining us, we are doing some stargazing. I'm showing you some highlights to look at tonight. Get your free astronomy packet by going to www.superchargedscience.com/astronomy, and it has even more stuff that you can do with your kids, including black holes and a lot of other really cool things, like how do you tell if you got a good pair of binoculars for stargazing and so forth. So make sure you get that download at superchargedscience.com/astronomy. Okay, so let's see. Let's look at a star that blew up. Now, this star blew up about 1,000 years ago, about 1054. And, excuse me, what's really cool is it's one of the very few supernova remnants that's still up in the sky. Now, you do need a telescope to see this, but with the naked eye, you can see where it is and where you need to point. And it's called M1. We call it the Crab Nebula. What's really cool is civilizations back then, 1,000 years ago, this thing was recorded as being visible both during the day and during the nighttime for about 2 months in different civilizations in their history, in their tapestries, in their writings, in their artwork. So it's really cool to be able to see that now, what people saw like 1,000 years ago. Okay, so where do you find M1? Okay, so M1 is going to be, wow, in the middle of nowhere. So we're going to zoom out, and you tell me where you think M1 is. Okay, let's see. Okay, let me put the pointer on it, and we'll center it. Okay, so you got it? So now I'm going to back out, and you tell me if you think you recognize any other constellations near it. Can you do that? You see anything you recognize yet? I hope so. Do you see Orion here? Okay, now do you see Taurus, the bull? So after you found Orion in his belt and the V, and you've seen the Pleiades over here, you're going to take this up, and this is going to be almost directly overhead. So you're going to find Orion's armpit, basically his left armpit, and you're going to find this really cool stop sign in here. And you're going to go halfway between, and that is where the supernova remnant is. Now, what does it really look like? Well, with the Hubble Space Telescope, it looks like this. And this is what we call, it's a pulsar. It's a star that's collapsed so much that it's super dense, and it's giving off radiation. It's giving off all different kinds of energy in different wavelengths in the radio all the way up through X-ray. And so you can see that in here. Okay, now this is not what you'd see in a telescope, not what you'd see in binoculars, but this is what the Hubble Space Telescope can see. The reason is, see all these red filaments and stuff? Your eye can't pick that up because it's in the wrong frequency, wrong wavelength. Okay, so all you'll see in a telescope, it'll kind of look like a little smudge, kind of like that. Actually, it'll be more like that, kind of like a smudge in a really good telescope. Okay, so that's M1. Okay, so let me show you how to find a galaxy. You guys want to find a galaxy? How about let's find a galaxy that's currently on a crash course with us. You ready? So far in the future, astronomers think that this galaxy is going to smack into us. So let's see it. And it's also twice as big as our galaxy. Okay, so what we're going to do, here, let's get rid of that and get rid of these. Now, do you see Cassiopeia? Here, if I get rid of all the labels. Okay, so this is that V we talked about with the dot. Okay, and this is the Pleiades. Now, you're going to kind of just look more north. So we're between northwest and north, and we're just going to look up above the horizon, and you'll see Cassiopeia. A lot of people know this one. Sometimes, right now, it looks like an E. Sometimes it turns so it looks like an M and a 3 and that sort of thing, and a W. So this is the Queen's crown. I wonder if it actually shows a crown. No, it shows a queen. Okay. Okay, so this is known as the Queen's crown. And what's really cool is it has a pointer star. It looks like it's going to be a little bit low. So let me change the time because I've set it for pretty late tonight. So let's just make it rise a little bit above the horizon so you can see it. Okay. So what you're going to do is you're going to find this, and we are going to find the Andromeda Galaxy. Okay. So what you're going to do is you're going to take there's two triangles here. Do you see them? Here, if I put this on, you can see them. Okay, you see the two triangles? Okay, so you're going to take the lower triangle that's bigger, and you're going to go about 1, 2.5 distances, and you're going to look right there, and you will see M31. And it'll look like this. It'll look like that with the Hubble Space Telescope. In a real telescope, it won't look like that. It'll look like that in about an 8-inch telescope. And in binoculars, it'll look like that. Okay, so you'll see something like that. So if you have binoculars in a dark sky, you'll be able to see this. You can actually see it. Kids will be able to see this with their naked eye. It'll look like a smudge, kind of like that. It won't look like a star, and you'll be like, hey, something's there. And you're right, and that's when you use your binoculars. And so this is the Andromeda Galaxy. So that one is called M31. Okay, so our North Pole, actually, if you live in Australia, you're really lucky because you have the Southern Cross. We don't have that up here, so we have the North Star. So let me show you how to find the North Star. Okay, you ready? And I should probably show you how to find the Southern Cross as well. But all right, so let's see here. So how do we find the North Star? How do we find where our pole is pointed to? There is one star that will not move throughout the entire night. Okay, so the North Star, do you think it's north? Yeah, it might be north. Here we go. So we got north. Now we're facing north. Okay, well, let's get rid of these guys. Okay. Can anybody find the Big Dipper? Show me the Big Dipper. Point it out. Do you see the Big Dipper? Where is it? Yeah, it's right in here, right? Big Dipper. Here, I'll put the labels on now that you've had a minute to look. Okay. It's part of Ursa Major, the big bear. And so, here, you want to see the pictures? Okay. There's the bear's butt, and this is the tail. So different cultures will have different names. This will be like the gourd in African cultures and so forth. So, okay. All right, so let's go back to what you're actually going to see tonight. All right, so here's your house. You look north, and here's the Big Dipper. In cities, you will be able to see the Big Dipper, and this one in the northern hemisphere is usually up, and you will be able to see it year-round. So the Big Dipper, what you do... excuse me, and there's actually a galaxy here, but you can't see it unless you're in really dark skies. And so the Big Dipper, what you do is you've got 1, 2, 3, 4, 5, 6, 7. You got 7 stars here. And this star is really cool because there are 2 stars that you will be able to see with binoculars. You see that? Now you see how close these are together? Look at that. So in binoculars, it'll kind of look like this. You'll be able to see like one and the other. In December, remember when I mentioned that Saturn and Jupiter are going to be really close together? They're going to be closer than what I'm showing you now here. They're going to be even closer than this. So they're going to be like on top of each other. Okay, not literally on top, just optically. It's going to be an illusion. Okay, so where did that Big Dipper go? Okay, so here's our Big Dipper. And so what do? So we find the bowl and we connect these two stars, and then we're going to connect them and go straight till we find a bright star. That is the North Star. It's also the handle star for the Little Dipper. Watch. You see the Little Dipper here? This one's harder because the stars are fainter, but the North Star, so this is the one star that doesn't move, and I can prove it to you. So I'm going to cause the stars to rotate. So I'm going, here, I'll leave the constellations up. Ready? And I want you to keep your eye on the North Star. Here, I'm going to take this off. Can you find the North Star again? Here, I'll move it around. Wow! Okay, now, can you find it? Okay, so here's the Big Dipper. Connect these two. Now you've got the North Star. Good? Now, if we ask this thing to move... Whoa, okay, sorry, I didn't mean to go that fast. Okay. Do you notice how all the constellations are moving around? I got rid of the ground so that wasn't confusing. Okay. So all the stars are going to rotate. Is it clockwise or counterclockwise? Counterclockwise, that's right. So they're going counterclockwise around this one star because the North Pole is pointed. Currently it's pointed there. Okay, and if we connect the stars and we put the horizon back in, you can kind of see how the stars are going to move throughout the course of the night. Isn't that cool? Now, what happens if we're not looking north? What if we keep this rotation, but we look west? What would you expect to happen? Yep, they're all going to come and set. Remember we talked about the planets setting? Oh, yeah, sorry. So it's daytime right now. I just turned off the sun. Sorry. So the sun's going to set, and then everything, the ground here will get dark. Okay. So the sun's going to set, and you can see Mercury. There's Venus. Okay. And then here are, you see Orion? Do you recognize him? Here he comes. Okay, and there's the Eye of the Bull. That one's setting, and Sirius. And now here comes the moon. Okay, so now let's turn. This is our view from the south. It's similar to the north. Okay, and now let's completely go east. What are you going to see? Are things setting? No, they're rising, aren't they? Do you expect that? Absolutely. Now this fuzzy thing, this is the center of the universe. Here, let's stop it here. So we're actually looking at the center of the galaxy right here. This is the Milky Way that you can see. And these constellations are going to be up this summer. So you won't be able to see these. These will be visible like at 3 o'clock this morning. Remember we talked about Jupiter being up at 3 a.m. Here it is. Okay, so this is really early in the morning. And so you can see the teapot here. Do you see the teapot? This is Sagittarius. We've got Saturn, Mars, Jupiter, like all the good stuff is here. You can see a ton of cool objects with binoculars. I'm not going to show you that because we'll do that in the summer. And here's the serpent, the Scorpio. And this is the heart of Scorpio there, the big red star. And this is the teapot pouring hot, steamy tea onto Scorpio. So you can see that this program, it really gives you a sense of the sky and what's happening and how things changed through time. And you could never get this from a paper chart. Okay, so let me pause just for a second there because I've got some more exotic things to show you. And hang on just a second. Oh, now the sun is rising. Okay, so let's put it back. So other things you can do with this program, so we can pause it. You can set the day and time. So I'm at, oh, we were actually in 2018. Okay, so 2020. There we go. That's why Venus wasn't where it was supposed to be. Okay, so date and time, and we will make it like 21 o'clock. There we go. Okay, so let's go back and look. So if I give you a part of the sky now and I take this off, can you tell me what we're looking at? What do you think? If I make it go a little faster, maybe that'll give you a hint. What are we looking at here? That's right. Which one of these is the North Star? Can you tell? Here, if I do this. That's right, this one, right? Because here is your Big Dipper, and these are the two pointer stars, and it's going around the North Star. Good. Okay, so anybody out there who's a Leo? You guys want to see where Leo is? Leo's usually it's actually a really easy constellation to find. Again, if you really are serious about getting to know the night sky, the easiest way to do this is to find some of those really bright stars we talked about, Sirius and Castor and Pollux and so forth, and then to start to know the constellations. And then those are your patterns that help you find the really fun stuff that I'm about to show you. Now, I know with Facebook, people jump on and off all the time. If you just joined us, hi, I'm Aurora with Supercharged Science, and we are stargazing. Can you tell? And so there's a free packet. Don't forget to get it from our website, www.superchargedscience.com/astronomy. I should really put that in the comments. Okay, so let's find Leo. You guys ready? Okay, so Leo, where did you go? Let's turn off. Okay, so for Leo, now, okay, so I can see. I know where Leo is, but imagine you don't. You can actually just type in Leo and it'll take you right there. Okay, but it doesn't look like much, does it? It's like, where is it? Okay, so let me zoom in a little bit. All right, so what we're looking for with Leo is a backwards question mark. Can you find a backwards question mark? What do you think? You see the dipper there, but do you see anything else? What if I help you here? Do you see a backwards question mark here? Can you see it there? Okay, so I'll put him on there. So this is Leo the lion, and in the night sky, you're going to be looking, where's our north, south, east, west? So he's going to be setting, what time did I set it for? Let's see, let's set it for today, 3:21, and this should be set to 21, let's say 20 o'clock. So about 8, well, no, it's still a little late. 21 o'clock, 9 o'clock, 9:30. Okay, so now we're gonna go find Leo. So where is Leo? Okay, so let's put the horizon back in. Okay, so there's your house. You recognize Orion and Taurus, okay? And we've talked about Cassiopeia with the galaxy there, okay? And then we talked about the Big and Little Dipper. They're gonna be towards the north, okay? And so you're gonna keep going east. So now you're gonna be facing east. Oh, you know what? We didn't talk about Coma Berenices. And then you're going to look a little high in the sky. So we'll talk about this one in just a second. Do you see the backwards question mark? Okay, keep your eye on it. I'm going to make it go away. Now do you see the question mark? Okay, so this is Leo's tail. You want to see what the picture looked like? Oh, usually people think of the question mark as the tail. I'm not quite sure what happened with this program. Okay, sure. So I guess this question, I've always thought of it as his tail, but there you have it. Okay. So there's nothing really interesting to see in Leo other than just being able to identify it and go, oh yeah, this is Leo right there. Okay, so Coma Berenices is really interesting. So if you can find the backwards question mark and you can find this little triangle, here, let's turn this off so you can see what it really looks like. So backwards question mark, and then you can find this triangle, you can start to find Coma Berenices. And what's really cool about this particular constellation right here, it's really faint, but you want to look right in here. Now, by the way, this constellation represents the beautiful hair of the Queen of Egypt. You know, she was so worried about the safety of her husband that when he went off to war, that she said she would cut her hair off. So her husband would be spared and he would not be killed during the war. And so when he returned safely home, she kept her promise, and that's her hair right there. So that's the story behind it. Okay. So what's really cool about this is if you look, if you look there with binoculars, you'll be able to see a grouping of stars here, and you'll be able to see part of an open cluster, which is really cool. These are really cool. In binoculars, it will look about this, and they're all kind of grouped together. On a dark night, they'll look like diamonds, which is really cool. Okay, and there's also all kinds of interesting things, like you can see two little stars close together there, and there's some of these objects are actually kind of telescope objects. Okay, so something else, I wanted to show you the beehive. So M44, so we're going to type in M44 and the beehive cluster. Okay, so this one's really cool. This is what it looks like in a telescope. If I were to show you, you would look, and this is what you'd see. So the question is, where is this thing? If I back up, do you think you can figure it out? Okay, I'm going to back up slow. Okay, so let's see if we can figure this out. Okay, so it's kind of close to this thing. Uh-oh, wait a minute. Do you recognize this? What was this again? That's right. It's Leo the lion. So if you find that backwards question mark and you go one way, you'll see a nice open cluster. If you go another way around here, you'll see the beehive from that question mark. Isn't that cool? Now, how far you go? Well, with binoculars, it's really easy to scan. And in fact, astronomers will usually have a pair of binoculars so they can look up and scan first, and then they swing their telescopes, and they have finder scopes and so forth. Which reminds me, I should probably introduce some telescopes. So this is a really small telescope. I think I got it for 80 bucks. It's a short tube. It's a 80 millimeter refractor telescope, which means the light comes in this way. Whoops, and it's completely turned around. Okay, and you put your eye in there. And so the light comes in. There's no mirrors or anything. It's all lenses. This is a finder scope. It has a bigger view of the sky. And so astronomers will use this. Sometimes not, though, because it's a different view than you would see in a telescope sometimes, because it's like mirrored or upside down, depending on the type of scope you have. But these are kind of like a bigger view of the sky, so you can kind of zoom in, because when you're looking through the telescope, it's really, really zoomed in, like I showed you with the software I was just showing you. So a lot of kids get really excited. Are you guys ready to do some stargazing? Okay, so let me see if there's anything else. I think we covered most of it. I was going to show you a couple of, I was going to show you the double cluster and Cassiopeia. Let me do that really quick, and then let's move over to telescopes. Okay. All right. So over by Cassiopeia, there is an object that is a double cluster that is super cool. And in a telescope, you will actually see that. It will look like this. Isn't that cool? So this is NGC 869. This is a double cluster. In binoculars, you're going to see that, which is pretty cool. Maybe more like that. Okay? Which is super cool. Okay, so where is this? If I turn on the constellations, do you think you can tell me where it is? Okay, let's look. Do you recognize anything yet? Yeah, what was this? Cassiopeia. Do you see how you need to memorize and really know your constellations? So that's where you want to spend some time tonight. Just go outside, and even if you only do one constellation a night, one constellation a week, eventually that's going to add up, and you're going to know the night sky just like that. Okay, and the night sky doesn't change that much night to night. I mean, except if there are planets. Doesn't change that much night to night. Okay, so a lot of parents usually will ask right now, this is awesome, I love it, I want to buy a telescope, what do I buy? And this is where I say, actually, it'd be great if you didn't, because telescopes are awesome, but they're useless if you don't know where to point them. And I know we just had a lesson in where to point them, but you need more practice than that. So the best thing is actually a pair of binoculars. Now, does anybody out there have like an inflatable raft? You know, the kind that are, they're really cheap. You can get them at the drugstore, and you put them in a pool, and they're like these little air beds with a tiny little pillow at the end. If you put one of those on the ground, you will be able to save your neck, and you'll be able to view a lot of stuff that's overhead and also kind of near the ground as well, and it's comfortable, especially if you add a sleeping bag and some popcorn and hot cocoa to it. And so getting a pair of binoculars with a star chart, with kind of what we've done tonight, with an app with your phone like Sky Safari or something that like Stellarium actually has an app as well. I haven't used it much because I prefer the desktop version. This is going to really get into you, really make it easy for you to learn the constellations. And there aren't that many constellations. And, there are weird constellations like Draco. Everybody wants to know Draco, the dragon. But it's huge. It takes up like half the sky. And nobody ever really uses it. Astronomers typically don't use Draco too much. In fact, I don't think I ever have. So, but they use these other ones, and they're just looking for patterns. And we're just looking for patterns so we can find other things. Now, the Messier Marathon is currently going on, and if you don't know about it, there is, actually, it's tonight. And what happens is astronomers will start tonight, or they'll do it all in one night, or they'll take a whole year. It doesn't matter. This is not a timed thing. And they will find every single object in the Messier catalog. So you start with one, and you shoot all the way through the bottom. I forget how many there are, like 110 or 102 or something like that. And they will find all of them. They stay up all night, and they find them all. And so the idea is that even if you only find 10 tonight, you've already got to start. So because in March through April is where all of the objects are visible over the course of the entire evening. Some of the ones are tricky because they land. I wanted to say they land. They set as soon as like the sun goes down, so you got to catch them really quick. So that's something that astronomers are excited about, and they're doing tonight. Okay, so I know we've gone really long. I wanted to make sure at least you got some good amount of content. How are you guys liking this so far? Are you okay if we go like another 10 minutes? Yes, maybe? Okay, I'm assuming it's a yes. Okay, so right now, while I shift gears, I'm gonna bring some eyepieces and stuff up here for you to see. I want you to type in the comment box right now the thing that you liked most that we've covered so far. So what is it that you really like the most? What did you not know that you're totally excited about? What maybe that you knew but you're like taking it to another level? Whatever it is, type it in. Tell me so we can do more of that for you. Okay, so go ahead and type it in now, and I am going to bring a telescope a little bit closer. Okay. All right. So a lot of parents will want to buy a telescope like this. It's cute, it's small, it fits on a shelf. Notice mine's dusty, I had to blow it off because nobody uses it. This one was about 50 bucks. It's from Celestron, and this is a very small telescope, and it's not even good for looking at the moon. This will frustrate your kids beyond measure. So any telescope that you buy, like from Costco, it's a doorstop. It's not really a telescope. I keep this one here. I don't remember who gave this to us or how we got it, but yeah, we don't use it because it's plastic, it's cheap, and the mirror inside is plastic and it's junk. So let me show you what we do use. Now this one is decent. I don't know if they make these anymore, but again, these are a set of 10 by 50s by Orion. So write this down, parents. If you have a pencil, I can give you some names really quick. These are ultra views. 10 by 50s are a good size. Any bigger than that and you're gonna get tired. For smaller kids, 7 by 50s are great too. I have a whole different video I'm gonna post tomorrow about how to tell if you've got good binoculars or not. And so look for that on my Facebook Live page tomorrow, or just my Facebook page. It won't be a Facebook Live. It's a video I had done before as a Facebook Live. So, so 10 by 50s or 7 by 50s, the 10 in 10 by 50s is the magnification. So I look through here, I see 10 times as larger as I would with my naked eye. The 50 is the millimeter size here. So these are 10 by 50s, okay? So so if I had 7 by 50s, which one's gonna see things bigger? Like if I look at a bird, yeah, I'm gonna see it bigger, larger in the 10 by 50s, right? Okay. What if I have 20 by 100s? You see them over there? These are huge. I just got these. They are by far like my favorite thing that I've gotten. They're enormous. They're the biggest, but not here. I'll try to get them over here. They weigh like 8 to 10 pounds. I had to get a new tripod. I don't even like tripods. I had to get a new tripod just for them because they're enormous. These are binoculars. Look at the size of my face compared to these things. But they're amazing. It's like having a telescope, and I can pick the whole thing up with the tripod, and it's only like, I think 12 pounds maybe, or 15 pounds. So I'm not muscling around a huge telescope. Okay. All right. Okay. Make sure that's not going to go anywhere here. All right. Okay. There we go. Okay, stay. So what's this other guy behind me? This is called a Schmidt-Cassegrain. And what's really cool about him, other than his drive doesn't work, but I've been working on it, so it kind of works. And so what's really cool is he's really short. Let's see if you can see it in the video. Yeah, and so your eyepiece goes, oh, sorry, it's hitting the electricity machine back there. Okay, so it's really short. The eyepiece goes in here. And this is a finder scope. And so what's really cool is this thing is 8 inches. So when people buy telescopes, you can tell already if it's a bad one, that it'll say 1200x telescope. Nobody cares about the magnification of a telescope. What we care about is light collecting ability. This thing is a light bucket. The bigger the aperture, the bigger the opening, the more light comes in and the more details we can see, the more stars we can see. So I don't care, because things are so far anyway, you don't care if you've got a 1200x or a 1500x. In fact, anything much over, I think it's 400 or 500x is useless anyway. So this is an 8-inch Schmidt, and it's got a lot of glass inside. And so here, if you can kind of see it, the light will come in, it hits a mirror back there, bounces forward, hits another mirror that's this way, faced inward, and then comes back out through a hole in the back, and that's where your eyeball goes. And so this one's a go-to. So ideally what's supposed to happen is you plug in what you want to see and it goes bzz, bzz. Actually what it does is it goes bzz, and it just keeps going around. So I'm still working on it. I think we've almost got it now, but it just keeps rotating and doesn't stop. Okay, so which is not a good quality for a telescope. I know there was a reason I got it cheap. Okay, so so anyway, so if you are interested in getting a telescope, and so you've done binoculars, you want to move behind, the best telescope I can recommend, in fact, I can even pull up their webpage. Well, I'll just tell you. It's called Orion telescopes because you're not paying for the name as you would with Meade and Celestron. They have really good quality stuff, but you don't have to pay for the brand name. And so you want a Dobsonian. So notice that this telescope, it's up high. And other telescopes are usually on like rickety tripods, you know, like this is on it. Well, I don't know if you can see it, but there's a tripod down there. And so it's hard for kids to see and it's easy to knock over and break. And so unfortunately people see this little cool little telescope up on a teetery tripod and they want that because that's in their mind what they think a telescope should look like. And then when they see a Dobsonian, it's a great big tube, but it's near the ground, like the mount is on the ground. But it's easy for kids. Kids can get in there, muscle it around, and they'll use it so much more. And the Dobsonians that Orion has been carrying lately are build your own. And so they're actually cheaper, they're not assembled, and your kids get to build their own telescope. So how cool is that? So, so Dobsonian, so whatever your budget can afford, usually they're a couple $100s, and they start at, usually I wouldn't get anything smaller diameter than a 6-inch. If you can afford an 8-inch, that's fantastic. A lot of people will get telescopes, use them once or twice, and then they're on Craigslist, or they're on eBay, or they're on Astromart is the other one. Those are classifieds for just astronomy equipment and cameras and stuff like that. So get yourself, if you really want a telescope, then I would recommend, highly recommend Orion Dobsonian. And no, I don't get a kickback from them. These are just ones that I have used. When we do our science workshops, I buy an 8-inch Dobsonian and give it away to one of the kids during camp. One of the kids that just, that has made the most progress during the week, it's his gift at the end, or her gift at the end, which is something cool that we do. Okay, we also give kids a free flying lesson. Isn't that fun? So they come to camp, and if they, the first kid to complete some challenges, they get a free flying lesson, which is amazing. Okay, all right, we should probably wrap this up. Let me pause here for questions. So kids, did you tell me what you liked in class so I can look those over? Yeah. Okay. So let's see. Oh my goodness, that looks great. Questions. I'm actually getting some types of, what kind of brand is the telescope? Okay, so so Dobsonians are the ones that I would recommend. This one is a Meade. This is an LX200. The gigantic binoculars, you can get them for maybe, I want to say $400 or $500 from Uberwork. I wouldn't recommend binoculars this big. They're just too unwieldy and too hard to manage. This is an Orion short tube, and the gold one back there, can you see it? It's like right, let's see if I can point to it. There. That one is, we're going to do a whole class just in solar astronomy. That telescope can look at the sun. None of these others should ever even remotely be pointed towards the sun because you will lose your eyesight. That telescope only looks at the sun. It can't look at any other stars. So I'm going to demo that later this coming week. And so you'll be able to check that out. It just looks at one little wavelength in one particular way. And so I'll show you that. And I'll show you what the sun looks like through there. And it's super cool. Okay. We have a couple of more updates. We're going to kind of close off class. So if you have questions, type it in now. A couple of questions I have is, what is the name of the program that you were using? It's called Stellarium. S-T-E-L-L-A-R-I-U-M. Stellarium. So you can download that for free. Just Google Stellarium and you'll be able to do that. You can put in your latitude and or just put your city, and it knows exactly how to orient things. If you want to get one of these are from Sky and Telescope. I think there's a link to it in the description. You can do that as well. Oh, wait, eyepieces. I didn't show you my eyepieces. This is so fun. The whole reason for becoming an astronomer is so you can have gadgets. Oh, this is heavy. So it's not enough just to have a telescope. Now you have to have eyepieces. And so each one of these eyepieces, depending on what we're looking at, let me grab one. So I will, here, let's swing this guy around. So if I'm looking at, say, the Pleiades, that's a much larger object, remember the Seven Sisters, than, for example, looking at like oh, like the galaxy, I would use the same thing. Or like looking at Venus would be different. So I can change out my eyepiece, and changing out the eyepiece does a couple of different things, one of which it will change my field of view, and it will change the magnification. And how to calculate those numbers, I did a whole different Facebook Live just on that, so I'll make sure you have access to that as well. This is a laser finder. We put lasers on our telescopes nowadays instead of finder scopes. We'll take this off and put the laser on. And it's not to fry the aliens. It's to, what you do is you turn the laser on, and instead of using this thing, I can actually look, and it'll put a dot in the sky of where I want to point my telescope. So the laser's aligned with the telescope, and it'll be really easy. So these are easy finders. You can always, I would put this on like all my telescopes. The other thing I use when I go to star parties is a headlamp. Everybody looks like a nerd, and we are proud of it. And this one has a red light option. Everybody's walking around with these things. The other thing that I used, we talked about this in our light class. Remember I promised you the polarizer experiment? Do you remember when I took the two, I think I still have them. I took the two, no, where's the other one? There it is. Okay. Remember we had two pairs of sunglasses, and I said, pretend this is a pair of sunglasses, and we popped out the lenses, and now I can rotate it, and now you can't see me, and now you can. Now you can't see me, now you can't. Remember we talked about that in our light class? Okay, so the astronomers do that. See, these are much smaller. Same thing. Because the moon changes intensity, it changes brightness. And if I were to look at the full moon with a telescope, it would be like, whoa, I couldn't possibly see it. But if it was like a brand new moon, or it's just a thin crescent, I could barely see it. So we need a way to adjust the amount of light that comes into our eye based on what we're looking at. So the moon in particular, so we'll put these two things together, and it's just a small version of these where I can change it to adjust and account for that. Does that make sense? Now, if you missed the class where we did this, just go back in the timeline and you'll see a class on lasers and holograms, and we talked about that. Other things, if you have light pollution in your area, you can get little filters that will cut out the wavelengths of light that scatter the light for light pollution. You can get those for your, these are for telescopes as well. I will have some luck with them. My favorite filter is the O3 filter, and I use that when I look at the Orion Nebula. So I'll look at the, here, let me show you the Orion Nebula. Remember that? Here, test time. Where's Orion? Well, how about I actually put Orion on here? Oh, wait, let me take this off. Okay. All right, where is Orion? Anyone? Can you see it? Good, very good. Okay. So when you look in here through a telescope, it'll look like, it'll be green. It'll look like this, but it'll be green because you can't pick up these wavelengths with your eyeball. Your eyes are tuned for green. But when you put the filter on, so usually what you see is a smudge around here. But when you put this special filter on, suddenly you can see all of these filaments that were invisible before, which is super, super cool. Okay, and I think that pretty much wraps it up. There's a few other things you can use to measure stars and stuff, but we'll do that later. This coming week, so we're going to take a break on Sunday. So we've been together for 6 days. Yay! Everybody cheer like crazy. Yay! If you missed any of the classes, Facebook will automatically archive them. Look in our video archive. We've done rockets and catapults and energy and physics, and we've done light, and we've done holograms and lasers, and now we are getting into astronomy. So this coming week, we are doing physics and chemistry. We are going to apply it to a field, and we're going to talk about black holes, and we're going to talk about pulsars and magnetars, and we're talking about blazars, we're going to talk about radio galaxies, galactic nuclei, galaxies themselves. I'm going to show you how you can find meteorites in your backyard tomorrow, tonight. And so we're going to cover a lot of different sciences this coming week. So I will teach your kids totally free, 10 o'clock Pacific on Monday through Friday. Wednesday's class is not on Facebook. I will send out a personal invite to everybody that's on our email list. We are doing a big class just in astrophysics of black holes. And that class is so big, and it actually has a special worksheet download. It's got some extra stuff I can't do on Facebook Live. So we've moved it to a different site. So if you want that class, keep an eye out for the invitation, and I'll make sure you get that. Just get on our email list so you'll get that. But that's a black hole class on Wednesday. So we'll be together next week on Facebook Live. Write this down: Monday, Tuesday, Thursday, Friday. And we will be doing all kinds of astronomy stuff with that. And it's totally free. There's no charge. I had a woman today who was really upset. Stop saying it's free. It's not. It is. You don't have to pay anything. At the end of a class, if you'd like more, I will give you resources for how to do that. For those of you who have not found the free online school that I put together last weekend, we've gotten tons of kudos on it. Thank you so much, everybody that's written and given me kind words about it. It really makes a difference. I love it when you tell me how this is working specifically for you and your family. Let me put it in the notes. It's superchargedschool.com. Totally free. You just go and start using it. It's easy. So if you don't know what to do with your kids with math or science or reading or writing or art or music, health and nutrition, it's on there. Go ahead and use it. It's my gift to you. You're welcome to use it as much as you like. Pass it on. It's just something I put together. There's about a month's worth of activities on there. Now, please note the math is with the science because math is the language of science. So you need to kind of do them together. You have to let kids know what they're learning for and why we should care. And doing it through the lens of science is really an easy way to do that. So math and science lessons are on there. Next week, we will be covering some math. I'm going to show you how to measure the speed of light using a bar of chocolate as well as some marshmallows. You can eat the chocolate if you want afterwards or not. It'll be a little melty, but that's okay. And so we're going to do some math calculations along with it. There's nothing you need to do special. If you want the materials list, I've already printed them. No, I haven't printed them. What have I done? I posted them. Yes, I posted them on Facebook Live, and you can find them there. Do let your friends know and anybody else you know of that needs help during this time. This is something that my family has been working nonstop for the past 2 weeks on to bring this to you. I don't know if you know this, but we're a small family business, and we've been doing this since 1999. I actually taught mechanical engineering at Cal Poly State University for a number of years and was at Stanford University getting a PhD in combustion in mechanical engineering. I was working on scramjet engines, and I really like things that go fast and blow up, so that was kind of my thing. So, but when I was there, I really got the opportunity to work with kids, and that's when I thought, wow, this is a lot more fun than some of these other things I was studying. So what I've done, I came back and I taught mechanical engineering, and then I also would teach to the K through 12 grades in the community that needed some help with science. So I've been doing that for over 2 decades, and recently, past 10 years, my husband came on board, and then as I've got 4 kids, I have a first grader and a first and fourth, and I've also got a 9th and 12th. And recently, my 9th and 12th have come on board, and my 12th grader is currently has been working with us as well as the 9th grader to help bring these materials to you. So it's kind of been a family effort. So when you do call our phone number, we are staffed entirely by human beings, and I'm usually the one that gets a lot of your emails. Tanya and Crystal, I want to give a shout out to them. They have been amazing. They are our assistants, so thank you both for helping out so much, and Kashmir and the other folks that have been helping us, like Nathan as well, trying to keep everything together as things are starting to break. We had so many people on last week's physics class last Wednesday that it broke. Like half the things broke halfway through the class, and I would say push this green button to get your bonuses, and people are like, there's no button. So we fixed that. The programmers that created that program actually have been working for us so we can deliver more to you. There's a lot going on. So I just wanted to kind of pull back the curtain and kind of show you what we're doing and what we're about. But we're just a family that loves science, and you should see my house. It looks like a science museum constantly. It looks like I'm in a telescope store here, but this is kind of what our house looks like too. So anyway, so we're going to bring the best of what we have to you. I will be teaching your kids math and science this next week. Please do let other people know. Let's bring some light into where it's really needed. And I really appreciate you having this time with me. You know, it's not something I take lightly. You took time out of your day to come and hang out with me and have your kids hang out with me, and that's something that's really special to me. So thank you guys so much. I will look forward to seeing you. I'm going to take a day off tomorrow, and then we will start back up Facebook Live on Monday. The lists for materials have already been posted, but don't feel like you need them. You can totally just participate with no materials at all. So again, I look forward to seeing you in the rest next week, and you guys have a wonderful week with your kids. Go enjoy the night sky and go have a lot of fun tonight. Take care, everybody.